G'day YouTube and welcome to another episode of Alex Does DIY. My name's Alex. This is going to be another update or progress on the plastic injection moulder. But I thought before I'd start on the actual injection moulding machine, I'm out of stock of parts that I sell. So I thought I'd show you how I actually make one of the parts that I currently sell, which is a boot badge or a trunk lid badge for our American friends that goes on my 1971 Toyota Celica. As far as I'm aware, there's certainly none commercially made elsewhere in the world. The badge is unique to this particular model on a 71, 72 model and possibly early 73 model Toyota Celicas. So that's, I think one or two guys maybe in the States have made them in the past. So that's why I started making these. The ones that I do make, as soon as I put them up on eBay, they do tend to sell pretty quickly. So I just thought I'd take you through the process of how I currently make them, which would hopefully explain anyway why I would go to all the time and effort and the expense and the trouble of making an injection moulding machine, or at least attempt to anyway. So I'll take you in closer to what I'm about to do, and we'll get this part made. The first part of the process, it doesn't take very long, but then I'll explain why it's going to be an advantage to have the injection moulder. So I'll bring you in closer on the table and we'll get this part done. Okay, so I think I showed in the very first video in this series this mould here. This is the mould for the actual badge itself. It shows what it looks like on the front. It basically says Toyota and has a small picture of a dragon there. And then this part here is the back of the badge. These are made out of silicon, and I cast the part using a two-part rigid polyurethane, which is done in a 50-50 mix. So we just measure that up on the scales here. This particular type of urethane, because there are obviously many types, gives me around about 5, 6, 7 minutes work time depending on the ambient temperature. So that's generally enough to obviously get it mixed up nicely and get it into the pressure tank. So we'll do that now. Now normally with these moulds you'd close the mould up and pour it in through the hole, but with this particular one being so small and the holes that I put in the top are a bit small as well for pouring through, I found it easier and quicker and better results if I just pour it in here, then put the lid on, rather than put the lid on first and pour it through a hole. Alright, so I've got 16 grams there, and I'll pour 16 grams of the other one, give me a total of 32, which should give me a little bit of excess. So just give that a good mix. And if all you're interested in is actually making one-off part or just a couple of parts, then obviously this is the method you'd go for rather than actually going all of the time and trouble and expense of making an injection moulding machine. And there's certainly plenty of really good videos out there on YouTube on people doing this sort of a process. So once that's mixed up thoroughly, obviously I've cleaned out my mould really well. Let me just pour that in. Like so. Make sure the top's going on the right way around, of course. Firm that down. Plenty of excess there, as you can see, coming out of these breather holes. I like to give it a good smush. You really should be wearing gloves when you do this. I'll be picking plastic off my fingers for the next couple of hours. I like to give it a good tap. You really want to. Your biggest enemy with any type of moulding like this is air, trapped air bubbles. So get all that excess in that hole there. So I like to give it a good tap, give it a bit of a twist on this one like this. That's fine, that should be good enough. And then we go in the pressure tank. Here's my pressure tank. This has been made out of a tank from a air compressor. Put that on there. If you want to get serious about any sort of urethane casting or using silicons like this and mould, you have to have this sort of equipment. Hose, bring that up the pressure, and I tend to run this up to around sort of 50, 55, 60 psi. Once it's brought up to pressure, I find it relaxes a little bit. You'll lose a little bit of pressure. Just top it up again, and that's good now. So that really, with the polyurethane, that only really needs to stay at the pressure for probably 10, 15, 20 minutes. But here's the thing, and again, this comes back to why I'm actually doing the injection moulding machine, is that even though this stuff will start to set within about sort of 10 to 20 minutes, at that stage it's still soft. I can't demold, especially with this stuff, because it's the badges, because they're so thin. I can't demold these for around about 5 or 6 hours is best. So at best case scenario, that really limits me to making no more than 2 realistically, or maybe 3. Maybe 3 a day, which I'd like to think, or all the effort I've been putting in, and this for me, replicating parts like this now has been a 2-year journey to get to this point where I've been able to produce parts that are saleable. For me to make a business out of this and make it commercially viable and sort of replace my full-time income, which is my ultimate goal, is to get out of my job and start a home-based business. I can't be producing 2 or 3 parts a day. That's just ridiculous. So the idea, obviously, then with the plastic injection moulder is that if I make a mould for this particular part, which is what I'm going to be doing first, I should be able to. I'm expecting to be able to pump out a part every, I don't know, 2, 3 minutes, 4 minutes, however long it takes for that molten plastic to set in the mould. So that's the reason why I've decided to go to all the effort and the time and the trouble and the expense to get this done. So anyway, I just thought I'd show that out of interest. Like I said, I won't take that out of the tank now until sometime this afternoon, probably. So time to move on. So I'll show you where we're at with that. Okay, so here's where we're at on the machine currently. I mentioned in the previous video about the clamping plates, which I've now cut down. They're a 20mm plate, so then I wanted something that wasn't going to flex under pressure. They're 500mm long, 500mm long, and I think I mentioned in the previous video that I was going to use, I had these, a box of these track sliders, or track rollers I should say, and I was looking at incorporating them in here to give me a smooth rolling action on the plates. The reason why I turned away from that initially was that it's just the size of the bracket that these came in, and again I'm only really using them because I've got them in my garage already, and I'm trying to save a little bit of cash rather than going and buying more new materials all the time. So it was a matter of contemplating exactly how I was going to make brackets to hold all this here, and how that was all going to work, and I decided that maybe I was just overcomplicating things and I'd try and make things a bit more simple. So what I ended up doing, I had some box section here. It's quite a heavy gauge box section. I took 2 lengths of this and I've actually welded this in either side. There's one length here and there's another length up here, I think you can just see there on camera. And these were for our plates to slide on, and they also have the secondary purpose of it, because these are the only 2 points really where our side rails here are attached to each other, so it adds some rigidity to the base. And then what I ended up doing was I took some angle iron, again some fairly heavy gauge stuff. You'll see there that I've just drilled and countersunk holes in there and tapped into the clamping plate, and the idea being that then hooks in on here and enables some sliding up and down. Now as often is the case when you have these ideas, you don't really know how it's going to turn out until it's done, and you know, I know as I've mentioned before, without having things like milling machines and being restricted purely just to a few basic hand tools, I'm never going to get any sort of precision anyway. But what I found with this is it's just going to be inadequate. You get too much play in the plates this way, you get too much angle movement in the plates side to side, and the same with this one here. So I started thinking, well, I can add another piece of angle bracket underneath, to right underneath this bar, and then maybe I'd need to extend over this way to really encapsulate this slide bar here. But then again, you've got, you know, flat steel running on flat steel, and you're relying on really greasing this up to get a smooth ride, and there's just a lot of friction involved. And so I thought, no, it's just not going to do. So I went back to the idea of the track rollers again, trying to figure out a way of dealing with all this excess bracketry, and how I'm going to mount it on here, and it just seemed a bit ugly. So as is always the best idea when you get a bit the thing to do when you get a bit stuck in a project, I put it all down and gave my brain a couple of days to think about a solution for itself. And so what I ended up doing is I took one of these. This is just like this axle is just like a riveted axle. So I just drilled the top out and punched the pin out, which enabled me to then take take the roller out. Once I got the roller out, there's enough meat on this middle section here that I was able to countersink that, and so I'll be able to use one of my countersunk screws here, again just sticking to the same M5 size screw that I have everywhere else on this machine. So that rides, you know, nicely in there. The next thing I did was just measure the width of the actual roller here and the concave section, and it measured out to 6mm, so I got myself some 6mm bar. That rides nicely on that bar. So the next step for me, what I'm going to do, take these angle plates off on these plates here. These, I've got to cut them a bit shorter, but these 6mm round bar I'm going to weld to the corners on this top leading edge and another one underneath, and then I'll screw 2 of these rollers onto each end of the clamping plate, one to ride on top and one to ride underneath. Now what I'm hoping is that with a minimum tolerance between the roller and the rod, plus the fact that these are such high sided, that just the 2 will keep them tracking correctly. If there's still some movement after that, I've got enough material that I can run a 3rd rod in the middle here somewhere and run another wheel further back on its side like that. So I'll do a bit of preparation in getting all that ready to go, and then I'll bring you back. So I've made numerous attempts to try and get this to work and line up properly with these roller bearings. I think I've gone through plan A, B, C, D, E and F, and I'm just completely not happy with it. But you know, you don't know until you try. So the next plan is to go for a different slider type system, which I think is more in line with a traditional injection molding machine. So what I've got is I've got some lengths of this is just some 16mm galvanised round tube. I'm going to run a length of threaded rod down the centre of that and bolt it between our 2 main rails here, 2 each side, and then I've got some 19mm galvanised pipe. I'll cut a section, you know, sort of 3 or 4 inches long, that'll get inserted into the clamping plate, and that 19mm is just the right size to slide nicely in and out over there. So that's the plan. So fingers crossed that's going to work out for us. So let's figure that out. Alright, so it's been a long day, but we've got this all in place now. I'm relatively happy with how this has worked out. So we've got the 2 16mm bars at either end. I've finished the plates, the sections of 19mm tube. I ended up having to hammer in or press fit into the holes on these, so I was quite pleased with that. You can't see it from that camera angle, I don't think, but I've also drilled a series of 8 holes into each plate, and they've been countersunk so that I can screw the mould halves to the plates. Now they do work, they do slide, and you can see this there, quite happy with that. And this one here does move, but it's a bit on the tight side, but this one's going to have the pneumatic ram on it. This one's just going to have a threaded rod, much like a hand vise, to position, but you know, they're really secure though. I'm quite happy with that compared to previous attempts. They do come together nicely. So that concludes today. I'm buggered. It's been a long day. But anyway, that's how the clamps are going to work. Quite nice. Alright. Thanks for watching.